Hi everyone, Mechanics of Materials, Chapter 10, Strain Transformation, Change in Volume. In this example, we have a green cube block which is constrained in a from sides and also bottom. A constant pressure of P naught, negative P naught in y direction is applied. From the top, we want to calculate the volumetric change of this block. Consider nu and E as the two constants. So as you can see in this problem, sigma y provided it's a kind of pressure like a negative in negative y direction, and that's a p naught provided in problem statement. Sigma z is equal to 0 in z direction. There is no stress applied to the block, and like in epsilon x in x direction, because it's just a block between two yellowish walls, the block cannot move, so it just a kind of constraint there. Epsilon x is equal to 0. And from Hooke's law, we do know epsilon x in 3D format is 1 over e sigma x minus nu sigma y plus sigma z. So if you replace sigma y with negative p naught and sigma z by 0 from here and here, you can rewrite your equation like sigma x. So if this is going to be 0, epsilon x is going to be 0. So this is a constant. So sigma x plus nu times p naught should be equal to 0. And that gives us sigma x is equal to negative nu times p naught. And if you remember from previous videos, dilatation is equal to E, and that's 1 minus 2 nu over E sigma x, sigma y, sigma x plus sigma y plus sigma z of a material. And in another words, E is equal to epsilon x plus epsilon y plus epsilon z. And we can also say dilatation of a material is exactly the volume strain. And what does that mean? It just says E is equal to delta V over V. Do you remember in definition of a strain? A strain is a delta L over L. So we can say delta area, the epsilon area, areal strain is delta area over original area, and epsilon V is equal to E or dilatation. That's why we call dilatation is the volume strain, and that's delta in volume over V. So one can say E is equal to delta V, and that's delta V epsilon V, and that's delta V over original volume. And as soon as we calculate this one, we have this one, we can multiply that by the original volume, which is A, B, C. We have like A, B, C of our block. We can easily calculate the change in volume. That's what we are looking for. So likewise, we can say areal strain is epsilon x plus epsilon y, like epsilon capital A. And we do know this is the formula for epsilon x. Likewise, this is the formula for epsilon y. If you add them up together, it just gives you the areal strain in a 3D plane is epsilon a 1 over e 1 minus nu sigma x plus sigma y minus 2 nu times sigma z. But for our problem, we are just working with the volumetric strain. So we already know sigma y is equal to negative p naught, sigma z is goes to 0, sigma x is negative nu times p naught, and E or epsilon v is equal to this term. So if we just replace sigma x is equal to negative nu p naught, sigma y is equal to a negative p naught, and this one is 0. So if we just replace these values in our equation, so we can have like E or epsilon V is equal to delta V over V, 1 minus 2 nu over E. And if you just factor out the P naught negative P naught, that's 1 plus nu. That's what we exactly have it here. And then delta V change in volume is the ABC original volume times E or epsilon V. And if you do so, that's our result. So change in volume is equal to delta V, and that's equal to negative 1 minus 2 nu over E times 1 plus nu times P naught times the original volume, which is A, B, C. Thank you. We'll solve more problems.